Hey, Tryout Middle School, welcome to another enrichment video coming to you from the shop, Mr. Groening. They've had a lot of follow-up questions and comments about the first video we did, which was about basic electricity, so I figured we'd do a follow-up to that, which moves on into another aspect of electrical energy and electricity. And what this is about how you get electricity to perform work. We know we learned from the other video that we can use electricity to create heat through resistance, to create light bulbs and data and other things like that. But how do we get electricity to make things move? How do we convert it into force and motion? Well, it all has to do with magnetism. Okay, hopefully you guys can see here. I've got a couple of magnets right here. And you guys have probably played with magnets before. And magnets, we know, we put them close enough together, we're going to get a little bit of force and motion right there. Just the attraction of these two earth magnets, we see some motion there. However, one thing we also know about magnets is that if we turn them around sometimes, we don't get that attraction. We get something called repulsion. So where the magnets actually repel away from each other. When I push them together, that one pushes away. That's because magnets have a north and south pole, and it's similar to plus and minus with electricity. And if I try to put two south pole or two north pole ends of magnets together, they don't want to be together. They repel. It's the law of, kind of like the law of charges, where opposites attract and like charges of like polarity, they repel. So you can see when I try to push this magnet over there, not only does it repel, but it actually tries to turn to get to that other side, which is the north. Now we have a north and south together. Okay, so what does that have to do with electricity? Well, you can create a magnet with electricity. It's called an electromagnet. And you can actually do this little project at home if you wanted to and make a little electromagnet. All you need is a nail. This is I don't know, it's like a 20-penny common nail, steel nail. It has to be made out of iron or steel. And if you happen to have some wire, most any kind of wire will do, but this thin wire works really well because you can get a lot of windings on it. You see I've got a good sized roll here. And what you do is you start simply winding the wire around the nail. And it might take some time. And you're basically going to wrap it all the way to the end. You can push the windings together as you go to keep them nice and neat. Wrap them all the way this way, and then continue to wrap back the other direction. You see how I left a little bit hanging off so we can hook up this wire to something when we're done. And we do the same on the other end. I actually took a wire roll exactly the same length, and I did that with this, and I have that right here. So this is a same thing I just showed you. This is a nail with the wire wrapped around it, and this is all ready to go. Most wire has some kind of insulation on it. I know this looks like just metal wire, but it actually has this red material that's on here is actually an insulation. It's kind of like a lacquer material. It's a very thin insulation. But in order for us to connect this to the battery, which we're going to do in a minute here, what I needed to do is I need to take some sandpaper and just kind of scrape that off. It usually comes off pretty easily. You can scrape it off with sandpaper until you get that shiny copper color, or sometimes you can even take a sharp knife and just kind of carve away from yourself and scrape it away that way. But once you get that off, now you have a good connection there. And what I have here is I've got a little 9-volt battery that I can hook this up to. You guys can see here. Turn this down a little bit. Now if I'm going to use some alligator clips here to help hold this on there, like that, if I can get it to stay on there. You see a little sparking happening there. All right, so now I've got electricity traveling through those windings there, and we should have something called an electromagnet. You can see with that 9-volt battery there, we've got a magnet, pretty powerful magnet. Pick up a whole bunch of what type of metal this is. Remember this from the metals lesson there. The type of metal that's magnetic is iron. So this is mostly steel, which contains mostly iron. So that's all magnetic. Like that. Now, why is this happening? The reason it's happening is because when you put electricity through a wire, there's a very tiny magnetic field around that wire. Okay, and it's minute. It's very small. It's not even measurable, probably. But if you take a bunch of that wire and you wrap it around, you can then concentrate that magnetic field. And you need the iron, or the steel, in this case, nail, in order to have a place for that magnetism to go to. It goes to this ferrous metal here. And now we've got an electromagnet. Electromagnet is got a lot of advantages over an earth magnet like this. So with electromagnet, it's a magnet you can turn on, you can turn off. As soon as I disconnected that battery, it's dead. It no longer attracts. It's no longer magnetic. So we have a magnet we can control. We also have a magnet that we can make more powerful or weaker if we want to, simply by either adding more windings, more wire, or adding more electricity, changing the electrical flow. So we can control it that way as well. We can also make this north and south just like the earth magnet, but we can change that by how we put the electricity through here. We've got a plus-minus connection on our 9-volt here. All we would have, if we connected that, we'd see that this was probably a north maybe, and this was a south. If we wanted to reverse that, we just simply reverse those connections on there. So you have a magnet that you can really control. So how do you use this to create force and motion? Well, there's a lot of different ways you can use electromagnets like this. Simply like this, you can see it's used to pick up metal. You can use it to pick up scrap metal if it's steel or iron. We can use it to sort metal if we want to recycle metal. Most metal that we use is recycled. And we want to separate the two different types of metals. We can use it that way. We can also use it simply just to move something, like if we want to move a lever or a switch or a valve. We want to turn something on, right? We can have that done automatically through electricity. The washing machine, for example, has lots of, they call solenoid valves in there that when the cycle goes to rinse, for example, it turns on a valve that starts sending water to the machine, things like that. Okay, so that's an electromagnet, simple one. Another device that uses electromagnetism that you can see just creates a little bit of movement is this bell. This is an old style bell here, and you can see a couple of electromagnets right here, and we've got a wire going to it, and there's a hammer. Okay, and so what's going to happen when I send electricity through these two magnets is, since this hammer is made out of steel, those magnets are going to attract that hammer over to them, and it's going to cause it to hit the bell. The thing is, though, we don't want it to just go over and hit the bell and make one little ding. We want it to go back and forth. So it's kind of ingenious how they do this. You have it's on a spring mechanism, and there's a connection here. The electricity has to go through this little connection in order to get to those magnets. So as soon as those become magnetized, and this thing goes over, that connection is broken. No more electricity going through the magnets. They shut off. And then, since this is on a spring, it springs back, and it reconnects that connection, which again charges our electromagnet. So that's how you get that back and forth motion. You can see there's a little spark here, a little arcing where the electricity is kind of jumping across a little bit, similar to the way a spark plug works in an engine. So that's a similar to like a solenoid switch. You just get something to move like that. So that's our bell there. Another way we can use electromagnetism, you're probably more familiar with this, is to use it for motors. Motors, we've got lots of electric motors used in all kinds of things at shop here. Everything's electric powered with an electric motor. We've done projects in classes in electric motors. And electric motors use the same concept of electromagnets. You can see there's a model here, working model of an electric motor. And we can see our electromagnet in the middle here, just a bunch of that copper wire wrapped around the steel core and iron core. And in this case, it's allowed to move. Okay, and on the outside of this one, we have a couple of earth magnets. So you can see they're labeled. This one has an S for South Pole. This one has an N for North Pole. And what's going to happen when I send electricity through this electromagnet, this side is going to become a South Pole magnet, and this side is going to become a North Pole magnet. So as soon as that happens, those want to repel. They don't want to be together, so it's going to start to push away around to right about here or so. And then once it gets over to this side, this is south pulling to north, it's going to change. The way the electricity goes to this magnet, as soon as it switches over here, this magnet now becomes, instead of it being south, it becomes north because of the way electricity goes to it. So it doesn't want to be there either. So it starts to swing back to this side, to track to the south, and then switches back to a south. So this electromagnet in the middle here is constantly switching north-south, north-south, causing it to repel and attract as it goes around there. I hope that makes sense. I hope I explained that right. That's difficult to understand sometimes, but let me show you how that's going to work. I've got a power supply here, DC power supply. So we just added about 6 volts to that, and you can see how that's causing that to turn. You also see probably a little bit of blue arcing there. It's hard to get electricity to a moving magnet, right, because you can't wire it, it will wrap up. So we have these contact points that are scraping right there. These are called brushes, actually. Every motor has those, and so they're a little arcing going on there. So, like I said, with this magnet we can control it. We can make it more powerful simply by adding more voltage, and that makes the motor go faster. So, electric motor, really easy to control the speed. We just add more electricity to it, more energy to it, and it will go faster. Okay. Now this one is turning. Looks like it's turning counterclockwise. It's turning in this direction. Okay. Now, the way we get that to turn the other direction, another advantage of electric motors, is we just reverse the way the electricity is going to it. So I just take my wires and reverse them, or my power supply, actually, I can do that with a switch. So I'm going to switch that. And now, this is going to go clockwise. So much easier to control. We had a gasoline engine, changing the speed gets complex with the fuel supply. Changing the direction is really complex because then you have to have a transmission. You can't change the direction of a gasoline engine. You have to change the output force direction to a transmission. So electric motors have a lot of advantages. Very few moving parts and a lot of control there. Now, the small motors that we use here for projects in the shop, they are pretty much like that. You can see the solenoid, the electromagnet in the middle there. The armature, it's called, right in there. And inside this little container are 2 magnets. There are 2 earth magnets in there. They're very small. Okay. Earth magnets, though, are typically not used in motors. Okay. Magnets like these, not very powerful. They don't give you a lot of energy for very long. So it's not very practical for some of the big motors that we use, that are used for everything. So what instead you have are a couple more electromagnets instead of earth magnets. This is a sander, a little palm sander that we use here in the shop. And this one's taken apart and broken. So and you can see our electromagnets here, the part that spins, just like we had in our little model there. But instead of having 2 earth magnets on each side causing that repel and attraction, we have, you can see here, we have 2 electromagnets as well. And see our coils there, and electricity goes to this one, making it a magnet. Electricity goes to that one, making it a magnet as well, much more powerful than most earth magnets. And that would be on top of that, just like on our model, and that would be causing that same result, which is the rotational force that we have. So that's an electric motor there. And that's how most electric motors, if you take them apart, you won't find magnets, you'll find electromagnets. But the small ones are a little bit too small for that, so you will find earth magnets in this. All right, let's see what else we have here. So another thing we can do with electromagnets is we can actually make sound. A speaker, such as this one here, actually I have one here that's taken apart, makes sound through this paper diaphragm. This diaphragm actually vibrates very quickly, and it makes sounds that way. It interacts with the air and makes sound waves. And the way we get that little diaphragm to vibrate is through electromagnetism. And we have here, you probably noticed on the back of a speaker is a magnet. There's an earth magnet there, and in the middle, just rip this one apart so we can see the inside here. You see a little coil of wire. See that little coil of wire? And so when we want to create sound, what we do is we take that sound, we convert it to electrical impulses, little plus minus impulses. Maybe they're greater, the little voltage changes in them that makes the sound different, makes it higher pitched or lower pitched or louder or whatnot. And those electrical impulses go to this little coil, which is, you can see that's going to be placed around an iron core. And that coil is what's attached to the paper. So, and since there's a magnet on the other side of that, so they're basically two magnets interacting with each other. And one's an electromagnet, one's an earth magnet. And when we put electrical impulses, those interactions is what makes that vibration and makes the sound. You can kind of see that. You can see if I can get it to make some sound here with a battery, 9-volt battery. We've got, let's see, probably just hear clicking. You guys hear that clicking? That is the just a very simple pulses that are going. Let's see if we can get this thing to bounce up and down. Yeah, you can kind of see it there. That one's kind of big, maybe. Got a piece of paper. No, that's not going to move. So you can, I don't know if you can hear that, but there's a little clicking there, and you can actually, on big speakers, you can actually see that movement. Big bass speakers, you can see that movement. So that's the way a lot of sound is created through electricity, again, through movement, through electromagnets. Yeah. So the other thing about electromagnets is you can actually use them in reverse. In other words, you can use them to generate electricity. We know that an electromagnet like this, the wire has a magnetic field around it, and when you concentrate that, you can get magnetism. But you can also, if you pass a magnet over an electromagnet, you actually can generate electricity. Basically, the electromagnet, you're converting electricity to magnetism, but you can also use motion to convert magnetism to electricity in reverse. And you can see there's we call that a generator. I've got a simple generator right here set up. And all I did was take an electric motor like the ones we use in the shop all the time for projects, and I attached it to another electric motor. And I've got a little switch here, and I've got a little light bulb here. And what's going to happen is I'm going to energize this. Let's get my wires connected here. I'm going to energize this and get our motor spinning. And once our motor is spinning, this shaft is going to cause that motor to spin, which should in turn light our light bulbs. Let's see if that's going to work. There it is. So this motor here, it's just a regular motor. It works just through the electricity going through. They got about 6 volts going through that. And there's another electric motor, very, very similar to this one. It's got magnets inside. So the coil that's spinning inside that, or the electromagnet, is actually taking that and converting that magnetism into electricity. So work in, motion in, electricity out. In this case, we have electricity in, and we're getting motion out of it. And that's how a generator works. So if you have a home generator, it's just kind of like a motor. It's being spun by something. It's probably a gasoline engine or a propane engine or something like that. And that's how all electricity is generated. The electricity you have in your home, you just need a way to spin a generator. And you can do that in any number, with a windmill, with hydroelectric power, any number of ways. I've got another example of that right here. Get this one out of the way. This is a little bit larger one. You guys may have seen this, and I've shown you this in class, but it's got a bigger light bulb on it. Oh, there goes my heat. And you can see when I crank that, I'm getting electricity out. So motion in, work in, electricity out. Okay, and there's a good example also of our incandescent light bulb, like we had, like I showed you in our first lesson, how we used resistance to create light, and forcing electricity through that little tiny wire gets hot and creates light. So that's a generator. So it's kind of hard to crank this. That's why, generating electricity, it's not an easy thing to do. But. All right, that pretty much concludes. Let me get you back up there. Pretty much concludes this part of this little lesson. It's kind of short, but something you can do, like I said, is you can make the electromagnet at home. You can use any wire for that. Be careful with these 9 volts when you use them. Okay? They can be a little dangerous. I have a little story to tell you about that. When I was getting ready for this, I grabbed this one, I threw it in my pocket, and on my way in here, I dropped my car keys in the same pocket. And the car keys must have gone across these 2 terminals, and I felt the heat from that battery in my pocket, so we got to be really careful. A lot of energy in this little battery. to start fires with them. You can burn yourself with them, but that's also going to discharge the battery pretty quickly if you let that go. Same with your electromagnet. Be careful not to leave that charge for too long on that 9-volt. It'll start to heat up a little bit as well, and it'll run down your battery pretty quickly. All right, well, feel free to comment, ask questions like I've had students do about these lessons, and hope you enjoy them and try this one. It's kind of fun.